the biggest exciting thing for me about the math standards is that it's less about memorization and more about thinking. So that's really exciting, but it's also challenging. I learned how to do math by memorizing a formula or memorizing procedural steps. And I really took too much time to think about why I was doing what I was doing. You know, it's just, well, you multiply this column and then you multiply that column, or you divide, you bring down, subtract. So it's procedural. And when I step into a fourth grade classroom now, I hear kids talking about regrouping and why they're regrouping. And those are conversations we never had. And so their understanding of mathematical concepts are much stronger. That's definitely exciting when you think about future careers, and if these are going to be engineers building bridges, and I don't want them to know just the procedures, I want them to know why they're regrouping and the formulas and the reason the formulas work. So in order for that to work, the instruction has shifted a little bit. You know, it's less problems, but maybe more complex problems, fewer but more complex problems that require students to not just complete tasks, but think about what steps do I need to take to solve a problem, and then how am I going to apply the mathematical knowledge I have to solve this problem.
When you think about the shifts in the standards, I kind of narrow it down to the three main shifts. And the first one is focus. And prior to the Common Core standards, we had a long list of things to accomplish at each grade level. And that has been narrowed a bit so we can go a little bit deeper into topics that previously we had to do a real quick drive-by. Next piece is the coherence piece. So the coherence strands have really supported thinking about, you know, what is my focus at this grade level and where is it headed? And it's very clearly defined on where maybe a certain strand starts in kindergarten and ends in second. Or we start with fractions, you know, just a tiny bit in first grade, but it's not a major standard, and then it kind of picks up in third grade and continues on. And then our third shift is rigor, which is similar to the complex text kind of conversation you hear on the literacy side. The way I think of it is, you know, if a student notices, comes to a generalization that something works, it's been through the process of modeling and reasoning and productive struggle and grappling with it. You know, proving why does that work? Why is when you have a half a jug of chocolate milk and you drink a fourth of that, how do you determine what's left in that jug of milk? Versus memorizing 1/2 times 1/4, and just after you have grappled with why it works, then you can procedurally be fluent with solving multiple problems with multiplying fractions.
You know, we always say, well, the math doesn't change. You know, this is still the same math that we were seeing 20 years ago, 10 years ago, 5 years ago in the math classrooms. The only difference is the students are being asked to apply it more and to dig a little bit deeper. And the pressure of doing that all for a test, I think, is what kind of throws people off.
If you're showing the direction of how the problem should be solved, they're going to give you credit for that. It all depends on what the problem is asking for. So even with the ELA part of it, if you answer the main idea question right and get the supporting detail question wrong, you get credit. It's no longer, it's just one answer, it's how you're explaining how you got to that answer.